Hello Python programmers. So in this video, we list down and explain to you 5 Python projects that you can add in your resume today, and they all are very different from each other. First one, we have a computer vision game. Then we have a GUI chat application. Third, we have a home surveillance system. Fourth, we have a Flipkart price drop automation. Basically this is a web scraping. Then we have a GUI tic-tac-toe game. Okay, so it's a mixed bag of all the projects. Now you'll be provided with source code, explanation and everything, but make sure that before you go ahead and download the code, make sure that you understand how the code works. Okay, at least you should know the basic commands of that program. Okay, and the reason behind this is very often the interviewers ask the questions from the projects that you have created, like how you have created this project, what is the library used for this project, and some of the basic commands of that library. So you should know these answers. So make sure that you watch that video. It won't be that long, and you can create and add them in your resume in an hour or so. Okay, so let's get started with our first project, which is a OpenCV game. Okay, hello Python programmers. So we have already seen the aim of the video. Now let's start creating the project straight away. But before that, we have to import a few packages. Install a few packages. So just open the command prompt and write pip install. And first package we have to install is OpenCV Python. So write OpenCV Python. Then we have to install MediaPipe. So pip install MediaPipe. With the requirements being satisfied, let's get to our editor so that we can start writing our code. Okay, so now we are into our editor. The code is already written, and as usual, I'll explain you each and every line and each and every command. Okay, so the first task is to import the required packages. First is MediaPipe, the short notation is MP. Then we have CV2, which is OpenCV. Then we have NumPy as NP, and then a specific class called landmark underscore pb2, which will return the coordinates of the landmarks, like what is the coordinate of your pinky finger or what is the coordinate of your thumb. Okay, now I know you are confused, but these things will make lot of sense as we move ahead with this video. Okay, so this is a specific class from our MediaPipe.framework.formats. Okay, then we have imported time and random, and this concludes all the package requirement. Okay, then we have created the class instance for first MediaPipe.drawing.drawingUtils. Okay, so this is for drawing. This is the class instance MediaPipe drawing. Then we have MediaPipe underscore hand, which is the class instance for MediaPipe.solutions.hands. Okay, this class will be used to find basically all the hand values. Okay, now for now you can ignore these part of the code or these lines of code, because these are for creating those circles that the user has to touch to score. Okay, so for now just ignore these values. Okay, then we are taking the input from our webcam. Now literally there are multiple methods to take the input from any video capturing method. There is method to take the input from your mobile camera. There is method to take the input from a wireless Wi-Fi cam. What I'll do is I'll provide a link in the description so that you can check it if you want. Okay, then with MP hands, MP hand is the class instance here. Dot hands, this is another function, and these are the two parameters. Okay, all the values are stored in this hands variable. These are the two parameters. First is the min detection confidence, right? So this is like the sensitivity of how sensitive the program will be to detect the features of the hand. Right, now there I like 21 or 24 points. What I'll do is I'll post a blueprint on the right hand of the screen. I guess there are 21. So how sensitive our program is to detect all those 21 points is what this parameter is concerned about. Okay, more the value, more will be the fake points. Okay, so 0.8 works for me. Then we have min tracking confidence, which is like the sensitivity of the tracking or the movement of the points. Okay, 0.5 works for me, and all these values are stored in this hands variable. Then while video is opened, which means that we are getting the stream from a webcam, and we are using this dot read method of OpenCV to store this data into this frame variable. Okay, then what's happening here is we are converting the input video into RGB. Okay, OpenCV works in the format of BGR, blue, green, red format. Okay, but MediaPipe works in RGB format. So if we want to perform the hand tracking, we have to take the input from the webcam using OpenCV, which will be in BGR format, and then if we want to do the hand tracking using MediaPipe, we have to convert it to RGB, and we'll do the vice versa after we have processed the hand features. Okay, first we have to flip the image, and then what we'll do is we'll get the height and width of the stream of the video. Now why are we doing this? Because the coordinates that MediaPipe gives to us is in the form of ratio. Okay, but OpenCV wants exact x and y coordinate to draw the circles, right? We are drawing circles here. So here basically we are getting the height and width of a video stream. Okay, then we are processing the input image, and all the data is stored in this results variable. Okay, and then as we have processed the video, we can convert it back to BGR. Okay, then once again forget these 4-5 lines of command till here, because once again this is the part of the object creation. Now if results dot multi-hand landmark, which means that there are points on the video or there is a hand present in the video, otherwise this value will be 0 and there is no else condition. So this if condition will be true if there is a hand present in the video. And once again for num and hands, these are the two variables. In enumerate results dot multi hand landmark. Now we are not interested in this num variable, we are only interested in this hand variable. Okay, because this hand variable is having the ratios of the hand features or the hand points. Okay, so we'll use MP drawing. We are calling the MP drawing class from here. Okay, so MP drawing dot draw landmarks. Okay, so this is a specific function here, and these are the parameters. First is the image on which these landmarks will be drawn. Okay, and then we have MP hands dot hand connection. So this is a specific class which will connect the points. Okay, it will draw simply a line between 2 points, and then we have this function MP drawing dot drawing specs. Okay, so it will have these parameters 1 2 3. Okay, so it will have these 3 parameters. First is the color of the point, then we have thickness of the point, and then we have circle radius. Okay, so thickness is the thickness of the pen which is drawing the circle, and this is the radius of the circle. Okay, now as it is very small, we'll get a point. Okay, now till now we have drawn the landmarks on our hand and we have connected them, but we have a big problem. We don't have the exact coordinates of any of the hand feature. Like we don't have the coordinate for our thumb tip, or we don't have coordinate for our pinky fingertip. Okay, and in our game we have to use our index finger to touch the object, so we have to get the coordinates of our index fingertip. So let's do that here. First we have to check if there is a hand in the frame. Okay, and then from hand landmarks, this is the variable in results dot multi hand landmark. So this will return a bunch of values, but we are only interested in the landmarks, in the ratios. Okay, so what we'll do is for point in MP underscore hands dot hand landmark. Now hand landmark is another class here. Then we are creating a variable normalized hand mark is equal to hand landmarks, which is this variable here, dot landmark. Inside this variable we are only interested in the landmark points. Okay, points are the values 1 to 21 or 1 to 24. Then we'll use the MP drawing class, which is normalized to pixel coordinate. So this is the variable name here, pixel coordinates landmark, and this class has these parameters. Okay, so first is the normalized dot x, normalized landmark dot x. Normalized landmark is this variable, the value extracted from here, and then normalized landmark dot y, so the x and y coordinate. As we know, these are the ratios, right? These are the ratios. So to get the coordinates, we have to specify that what is the width and the height of a video frame. So image width and image height, and here we got the x and y landmark, but they are not string or integer. They are sort of a dictionary. So to make them usable, first of all we had to convert them into a string. Okay, so this point variable is the variable in which all the point names and their coordinates are saved. So we are only interested in landmark.index fingertips. Okay, so we'll specify here if point is equal to hand landmark dot index fingertip. For any specific point, there is a list on the right side of your screen for all the hand points. You can select any of them, and after getting the coordinates we have to draw circle to that. Okay, so cv2.circle, and these are the parameters inside. First is the image on which we want to draw the circle. Then we have the coordinates. First is the pixel coordinate landmark of the 0th index. Okay, so this has two values, x and y. X is at the 0th index and y is at the first index. Okay, so pixel coordinate landmark 0, this variable here, and pixel coordinates landmark 2. This is the radius of the circle, this is the color of the circle, and this is the pen size or the size of the pen which is used to draw the circle. Okay, so we have drawn the hand landmarks and we have also drawn a big circle on our index finger. So next task is to draw the circles which the user has to touch to score. So first of all we have to create two variables. First is x enemy and y enemy. These are two random numbers from 50 to 600. This is actually the height and width of the video stream that we are getting. It is actually 640 and 480, but I am giving some space so that the circle is not formed outside that range. Okay, so after we have specified the x and y coordinate of the random circle. Okay, so sorry for stopping the recording. Actually, there was a light cut. Anyway, after we have specified the x and y coordinates of the circle, what will happen is after this while loop is running, this enemy function is called. Okay, this enemy function is called, and inside this enemy function we have called these global values score, x enemy and y enemy. For now you can ignore this score value. So x enemy and y enemy, we are drawing a circle. The parameters are the image, the x and y coordinate, the radius, the color, and the width of the pen used. Okay, so a random circle is drawn at a random point on the screen, right? And the user tries to catch that point or circle with their index finger. So if pixel coordinate 0 is equal to x enemy, or pixel coordinate for x enemy plus 1 and for x enemy minus 1. We are doing plus minus so that this condition is executed as soon as the user comes near to this point. Okay, so that they don't need to exactly rest both of the circle at the same location. Okay, even if they touch, this condition will be executed. Okay, then I'm just printing found here so that I can make sure that this condition is working fine. Then we are assigning another random x and y coordinate, and then we are creating a score variable. Okay, so we have already created a score variable here. Okay, so initially the value of score is 0. As soon as the program is started, the value of score is 0. But as we move ahead, as soon as the user connects the circle at the index finger to the random circle, the score is incremented by 1, and then we have to update this code. Okay, so how are we updating this code? First of all, we have created this font variable. This font variable will store the font of the text written on the screen. So this is like a font that comes with OpenCV, Hershey Simple. Then we have specified that what will be the color of the text, and then we are putting the text. So cv2.putText, this is the function used to put the text. First parameter here is frame, the image on which the text will be written. Then we have text, then we have coordinates at which the text will be written, then we have what will be the font size, then we have color, and then we have specified the style of our text. Okay, and after that we are calling this enemy function. As we have specified a new x and y coordinate, this enemy function will be called and a new circle will be formed at new random value. Okay, so this will complete the game logic, and the only thing left is to create a exit condition for this while loop, for this while infinite loop. So if cv2.wait key, okay, so we haven't displayed the output to the user, so we are using the cv2.imshow method to display the image to the user with this text. Okay, hand tracking is the text of the GUI heading, and image is the variable, or image is the value that will be displayed. And then we are creating a wait key. Wait key is q. So as soon as the q button is pressed, this while condition will be terminated, and we'll see our final score here. And this is breaking, which is terminating this condition, and then we are releasing the video and cv2.destroy all windows. Okay, so this is it. This was a short video. I guess it was not short anyway. This was a video in which I have shown you how to create a fun game using MediaPipe and OpenCV. Okay, so meet you in my next lecture. Bye bye. Hello Python programmers. So in this video, I'm going to show you that how you can create a home surveillance system using Python. So first of all, let's understand the idea behind this project. So we'll connect a video recording device with our Python program. It can be a mobile phone, it can be a wireless camera module, or simply your webcam. For simplicity, we're going to use a webcam only, but if you want to know that how you can use the external modules like mobile camera or Wi-Fi cam, then I'll provide playlist link in the description. You can watch that playlist. Okay, so moving ahead, the video is recorded, provided to a Python program. Then what our Python program will do is it will detect whether there is a human face or not, and if there is a human face, it will store the exact date and time at which the human face was present in front of camera, and then store it into a specific folder. And also it will record all the activities that human face performed in a video file, and only the human activities will be recorded. So this is what our project is gonna be. This is a small home surveillance system program. So first of all, let's see that what is the system requirement for this project. We're gonna use many packages, but most of them comes pre-installed with the vanilla Python installation. The only thing that you have to install is OpenCV Python. For me, this is already installed, so it didn't take much time. Okay. So with this being said, let's get to our editor so that we can start writing our code. So first of all, what we have to do is we have to import the required libraries. So let me quickly import them, and then after that, I'll explain you that what libraries are used for what task. Okay, so we have imported the required libraries. CV is OpenCV here. It will be used for all the image detection tasks, and then time and date time to get the exact time at which the face was present, so that we can save image with the same date and time. Okay, argpass will be used to combine all the images and create a video of all the action that face was performing. And as we know, OS is used for file handling. Okay. Now, what we have to do is we have to import a face cascade. Now, what is a face cascade? A face cascade is a XML file which has all the properties of a human face. Now, there are many cascade files. Cascade for cat face, cascade for cars, cascade for nose, cascade for eyes. But here we are taking the example of human face. So we'll use the cascade of human face. I'll provide the link for both the cascade and this Python program in the description. It will be my GitHub repository link. Okay, so we have used the cascade classifier class of our OpenCV to open this hard cascade and extract all the properties from it. Okay, then what we have to do is we have to create a video variable to take the input from our webcam. So we'll simply write a video capture. Okay, and we are using our webcam here. This is why we have to write 0. If we were using any external source, we'll write the data here. Okay, then what we have to do, we have to create an infinite loop and then extract the data that is present in our video variable. Okay, so it will return two values. First is stack and second is frame. Frame is the variable in which the actual data is present. Okay, so it will be video dot read, and if frame is not none. Okay, if frame is not none, none, then what we'll do is we'll convert our image into grayscale. Okay, so we have converted our colored image into grayscale. We are using the CVT color class of our OpenCV, and there are two parameters. First is frame or the picture that we want to convert into grayscale, and then this class cv2.color. BGR is blue, green, red to gray. Simple English. Now what we have to do is we have to detect if there is any facial feature in this gray variable, and for that we'll be using this face cascade. Okay, so I'm going to create this face variable. Okay, so we are using the detect multiscale class of our OpenCV to detect the features of our face cascade, which is our R cascade of face on this gray variable. And these are the scaling factors or the precision factors. I have explained them more clearly on my previous video of face detection. I'll provide the video link in the description. Okay, then what we have to do here is if there is a human face, then we have to draw a rectangle or a square. Basically it's a square only. We have to draw a square around that face, that green square. Okay, okay, so we have stored the data in our image variable, and we are using the rectangle class of our OpenCV. These are the parameters inside. First is the frame, the image on which we are going to draw this rectangle. Now we are returning the colored image to the user. This is why we are writing this frame here, not this gray variable, because this gray variable will only be used for image detection. It will not be displayed to the user, nor it will be saved in the video. Okay, first is this frame variable, our colored image, then the x and y. Okay, so this face variable will have four values: x, y, w, and h, which is starting x and y coordinates. If I explain you in lay terms, let's say that your human face is on a graph, and the starting point where your face starts, that coordinate x and y is this value. Then the width of your human face, width of your face and the height of your face. Okay, so first value here is this x and y inside these brackets. Then the third value is x plus w and y plus h. Now if you want to create a rectangle, you should know the height and width. This is what we are doing here. First the starting coordinate, then the width, and then the starting y and the height. So this is how we'll draw the rectangle. Then we have the color of the rectangle. Here we are drawing green, and the last parameter is the width of the rectangle, the width of the pen that will be used to draw the rectangle. Then what we'll do here is we'll use the date time to record the exact date time at which the human face was present in front of the camera. Okay, so we are using the now class of our date time, and this is the style of our date time we are choosing here. First is year, then month, then day, then hour, second, minute. So this all data will be the name of our image file. Okay. So let me first write, then I'll explain you that how this data will be present on our image. Okay. Okay, so we are using the I am right class of our OpenCV. Then the name of our file or the name of our image file will be face detected. Then the exact time. Okay, let's say face detected 2021. What is the month? What is the date? I don't remember. Okay, so 5th is the month and 15 is the date and time is 2:33. So all this data will be present in the file name. Okay, dot jpj. We are saving this in the jpj format, and then the data that will be stored in this jpj file, which is this image variable. Yeah, this image variable, I guess we haven't indented them. Okay, so let me indent. Okay, great. So we have saved the images with the human face. Now what we'll do is we'll use our im show of OpenCV to display, let's write home surveillance and frame. So we'll display our frames or the video to our user, and then we are creating the key variable to close our window. Then if the key is equal to order of let's say q, if the user presses this Q button, this key will be triggered and our window will be closed. And this is where the main task begins. Now we have to collect all the images and then store them into a video. So this is how you will do. First of all, what we have to create is we have to create a argument parse class variable. So let me first write, then I'll explain you that how things are happening. Okay. Okay, so we have already created our argument parser class instance. Then what we are doing here is we are adding the output, which is our MP4 file, and the input, which is our JPJ image, into our argument parser. Then what we have to do is let's create the arguments. First is the directory or the path where our images are present. So they are present in the same file where our Python program is. So we'll write simply a dot here. Then what we'll do here is, just a second. Then the first is input. So argument of the variable name is extension here. So we'll write extension and do the same for the output. Then what we'll do is we'll create a image variable and we'll store a empty list in this. This list will have all the names of our image files. Okay, so let's do one thing. Let's create a for loop which will iterate through all the files in our folder and see if there is a jpj file or not. And if there is a jpj file, it will add it to our image list. Okay. Okay, so we have created a for loop which will iterate in our directory path, which is the same path in which our Python program is present. Then if f, which is a file, ends with extension, which is .jpj, then we'll append our image list with that file name. Okay, image.append f, which is the file name. Okay, so then what we have to do here is we have to find out the height and width of the video. And how can we do that? By seeing what is the height and width of our first image. Okay. Okay, so now what we are doing here is we are opening the first image in this image list and storing this into this image path variable. Then by using this cv2.imread method of OpenCV, we are opening that image by specifying the image path here. Then frame.shape, it will return three values. First is the height, then width, then channels. Okay, so then what we have to do here is we have to use the cv2.videowrite for class to specify that what will be the encoding of our video. Okay. Okay, so we have specified the encoding here using the video writer for class of OpenCV. We have specified that what will be the video format and all the things like the height and weight, the encoding, the output extension. We have specified all the values here. Then comes the main part. We have to write all the data. Then comes the main part. We have to use all the data, the encoding, the input output extension, all the things to write the images on our video file. Okay. Okay, so we have created a for loop which will iterate through our image list, which is having the names of all our image files. So first in this image path variable, we are storing the path of all the images one by one. Then using the cv2.imread method, we are reading the data of the image file at this specific path. Then we are simply using the write method to write all this data which is present in this frame variable, which is the data of the image, into this out variable. Now what is this out variable? This out variable is variable with all the encoding and the extension, everything. Okay. Then after this task is done, we'll break our for loop, which means our task is done. Then we'll simply do video dot release. It should be release and cv2 dot destroy all windows. Okay, so let's run our program and we are getting a error straight away. So from date time, import date time. I guess we are getting an output. Let me run this program once more and see the output, because I wasn't paying attention this time because I was expecting one more error. So yeah, let's go back. Let's run our program. Yeah, this is my face. It is getting detected. This is the moment. And no face, face, no face, face. Okay. So let's press the Q button and it is freezed because the video is getting saved. Let's go to the folder. We are getting all the images here. And then this is our output video. Okay. So let's open this. Brilliant. So this is what the video will be. It is showing all the movement of the human face, and we are seeing a delay here because it is a slideshow of all the images. It will be very slow. And yeah, this was it. And here you can see the frames are missing in which the face was not detected. Okay. So yeah, this was it. This was a short video in which I have shown you, actually it was not short, but anyway, it was a video in which I have shown you that how you can create a small home surveillance system using Python. And I'll meet you in my next lecture. Bye bye. Hello Python programmers. So in this video, I'm going to show you that how you can create a real-time chat application using Python. So first of all, let's see the output that you can expect from this video. Okay, so here you can see that these are two different systems. Let's say this one is computer A and this one is computer B. So both have their chat application GUI open. So to start off the chat, both have to press this start chat button. Okay, so let me press. Okay, so to send the message, you have to select this entry widget and then let me randomly write something and press this send button. So you'll receive this message on the sender's end, you this message, and also at the receiver's end, client this message. Okay, so let me send from our computer B also. So let me write some random shit here also. uh, Press enter or this send button. It will take some time to reflect the message on this one. Here you can see the message is reflected here, and you can now go crazy and write anything here and have a chat with your own. Okay, so yep, this is the application that we are gonna create in this video. So pretty cool. Let's get to our editor and see how we can create this. Okay, so now we are into our editor. So first thing that we have to do is we have to import the required libraries. All the libraries that we are going to use in this project comes pre-installed with vanilla Python installation. So you don't need to install any external package. Okay, so let me quickly import the libraries so that we can move ahead. So this code will have, or this project will have three sections. First section is the GUI of our chat application. Then we have the sending of the message. Then we have the receiving of the message. So I'll treat these three as separate sections. So first of all, let's start off with the GUI part. So we have already imported Kinter. Let me initialize this by creating a TK instance of the TK class instance. This root is the instance of the TK class. Then what we'll do is we'll define that what will be the geometry. So geometry of our Kinter GUI. Let's say 300 by 500. I've tested these values. You can try uh, your own values. Okay, then what we'll do is we'll config it to white color, because the buttons that we are going to use have a white background. So we want them to somewhat merge with our GUI. Okay, so why have I written this here? So BG is equal to white. Okay, so root dot config, the background color of our GUI is white. Then we have five components here. First is the start chat button, which will connect us to our second system. Then we have the entry box on which you'll write the message. Then we have the send message button, that small WhatsApp button of send. And lastly, we have our big list box, which will display all our messages. Okay, so let me quickly write them. Then I'll explain you that how they are working or how they are created basically. Okay. Okay, so now our GI is complete. First of all, let's start off with the buttons. Now, we want these images as buttons. So we have these two images. First is for start chat and second is for sending of the message. So what we have done here is we have used this photo image class of our Kinter library to first of all load these two images. First is the start PNG and the second one is the send PNG. This is the name of our PNG files. Okay. Then what we have done here is we have created a button. Okay. First parameter is root. Second is the image that you want to treat as a button. Normally here we write a text. So it will create an ugly rectangle looking button which will have that text, but we want an image here. So we are writing this image parameter. Then the third parameter is the function that this button will trigger. So this is this function. We'll assign tasks to this later on, but for now it is simply passing. Okay. Then we have the border width or the width of the button. So we don't want any width. So we are writing 0 here. Okay. Then I have placed this button at 90 of X and 10 of Y. So 90 units of X axis and 10 units of Y axis. Now I had tried these values on my Kinter GUI. If you are creating GUI of different size, then you can experiment with these values. Okay. The same is for our send message button also. Only thing that is different here is that function is thread send message. This will send the message and we have placed this at x is equal to 260 and y is equal to 440. Okay, now the next thing is this entry widget or this entry box. this will accept the value from the user and send this to our client. Okay, so first we have created this message variable which will store this string variable. Okay, then we are creating this entry widget here. First parameter is root, the tk instance. Then we have the text variable, which is the message variable here. Then we have the font. So it will have three values. First is the font style, then the font size. This is the size and style of the text that will be written inside the message box. Okay. Then we have the third parameter, which we can either write bold, italic, stricken, or simply normal, which means a normal text. Okay. Then we have the border. So we want a moderate border. This is why we are writing 2 here. Then the width of our entry box. Then we have placed our message box at x is equal to 10 and y is equal to 444. Okay, the last but not the least is our list box. This is the section on which our message will be displayed. Now let me run and show you. Yeah, where is our GUI? Okay, so this is our start chat button. This is our send message button. This is our entry box, and this is our list box that we are talking. So first parameter here is root, the tk class instance. Then we have the height of our list box. Okay, so the height. Then we have the width of the list box. Then we have placed this at x is equal to 15 and y is equal to 80. Okay, so then we have closed our main loop. Okay, so this was the GUI part. So first of all, let's start off with our receive message function. Okay, so this receive message function will be initiated as soon as this start, where is that button? Yeah, this one, this start chat, what was the name of that button? What was it? Okay, so start chat button. As soon as we press this start chat button, our server will be connected to our client and we can receive the message from them. Okay, so let me quickly write the code. Okay, so now we have written the code that is required to receive the message from our client or from the sender. So first what we have to do is, after this button is pressed, this start chat button is pressed, this func function will be called, and what this will create is, it will create a thread, a separate thread for our receive message. Now why are we creating a separate thread for our receive message task? So we have two tasks happening simultaneously. First task is happening in the background, which is constantly looking for messages that is sent from the receiver, and also we want to send the message from this computer or this system also. So we need two tasks to happen simultaneously. This is why we have to create separate thread for send and for receive. Okay, so we are using this threading dot thread class here. The target is this receive function. Okay, so t dot start, which means that the thread is started. Okay, then let's come to this receive function. So first of all, we have created this socket class instance, which is this variable listen socket. Then we have this port number here, which is 3050. Now make sure that this port number is same as that of the second computer's sending port number. Okay, so receiving port number of this and the sending of the second one should be the same, and in the same manner the receiving of the second system should be same as the sending of this system. Okay, we haven't created the sending one, we'll do that very soon. Then we have the max connection, the maximum number of connection that can be established with this client. Okay, then we have the listen socket dot bind. So we are establishing the connection here. The first is empty because we are receiving. Okay, and then we have the port number. Now you must be wondering why I have skipped this line. Now this line is not useful in our code. I mean, this variable ip is not used in our code, but we need this value. So let me print this out. Just a second. We need this value because we have to specify that what is the IP or the host name at the sender's end. So this is why you should know that what is the host name. I'll show you that where it will be used and how it will be used. So first of all, we have binded it. We have established the connection. Then listen socket dot listen. So we are listening. We are waiting for the sender to send the message, okay, with the max connection of 99. Then after a message is received, we need the client socket or the packets, which can be achieved using this client socket dot accept class. Okay, so this will return two values, the message that the sender has sent and also the address, although we do not need the address, but it provides two values. So anyway, then we have to create an infinite loop which will run infinitely, and it will receive and decode the message. So this send message variable will store the decoded message. So client socket dot receive, it will receive the message from this client socket or from the client, and it will decode it. Now what is this value? What is this 10 1024? This 1024 is the number of bits that this client will accept, the length of the message that this client will accept. Okay, now if the message is not empty, which means that the sender has sent some message, we want to insert this into the list box. Okay, and this loop will be executed after every 5 seconds. Okay, so this is why time dot sleep. Have I imported time here? Yeah. Okay. So we are done with our receive part. So let me run this and let me execute the program and send the message from my second computer. So I hope this will work. Okay, so the message is sent, but it is not received here. Oh yeah, it is received. So our receive part is working perfectly. Now let's work on our send part. Now the initial part will be the same. We have to create separate thread. So th is equal to threading dot thread. Okay, so let me write, then I'll explain you. Okay, just wait for a second. Okay, so now we have written the code that is required to send the message. We have already created a separate thread for our send message also, and I have given you the explanation that why are we creating the thread. So let's move on. So this function, send message function, is called in this thread. Okay, so we are calling a global s variable. So why are we calling this variable, and what is this, what is the use of this s variable? So sending the message means we have to establish the connection. We have to connect with our second computer, and this happens only once. Okay, so you send the message, the connection is established. After that, you have to just keep sending the message. The connection is not required. This is why the first time only, initially the value of s is 0. As soon as the program is executed, the value of s is 0. First time you press this send message button, this s value, I have not incremented, I guess. Yeah, I haven't incremented. So s is equal to s plus 1. This will be incremented by 1 because we want this part, the connection part, only once. So if s is equal to 0, first of all, we have created this socket instance. Okay, then we have the host. This is where we have to use the IP variable. Okay, so you have to run the same command in your second computer and just note down what is the host IP or the host name and simply write it here. I'll show you that what changes you have to make for the second PC. Just give me a second. Or what you can do is just leave this section blank for now. At the end, I'll show you that what changes you have to make for the second computer. Okay. So port is 450. This is the same port that is present on the second computer's receiving part. Okay. Then we have to connect our second PC. Then we have to get the input from our message box, which is this entry widget. Okay, it will be stored in this msg variable. Okay, then we have to insert this message into our list box with the initials as u, so you have sent this message. Then we have to send the message using the socket.send command. Okay, what is the parameter inside message.encode? So a encoded message has been sent to the second PC. Okay, then we have to increment the value s by 1 because we don't want to make the connection again and again. Okay, so next time you press this button, which is the second time, third time, or fourth time, or infinite number of times, this if condition will not be executed, this else condition will be executed. Message will be extracted from our entry box. It will be entered in our list box, and s dot send, we have already specified that what is the value of s in our th thread, so it will automatically send to that connection. Okay, so let me run this program. Let me go back, open the PowerShell window here, and let me quickly run the program on both my system. Okay, so the connection is established. Now let me write some random stuff here. Okay, so we are getting an error. S.connect takes exactly one argument. Actually, there should be brackets, I guess. Yeah, actually, they should be inside the brackets. Okay, so let me save this and run the program again. Do the same for our second one also. Server is started. Let me write some message here. Okay, unsupported socket and int. But the message was sent. The message has been received on the second system, but we are getting an error. So let me sort. Okay, so s. Okay, so the variable name is different. Yeah, the variable name should be different here. It should be not. It should not be s because we have s as our socket instance. So let me xr. Let's say. Okay. So now let's try this once again. Let me close on the second system and open the application once again. It's a bit hectic because you have to be virus from 3 dates and use both of your hands. So yeah, it's a bit tricky. Okay, so let's start the server. Started the server on the second end also. Sending the message from the second system, checking the receive. Yeah, so it is working. Now let me write the messages and send from this part. Okay, so yeah, it's working. It's working perfectly. So yeah, this was a short video in which I have shown you that how you can create a real-time chat application using Python. So there are a lot of modifications that you can use, that you can do to this project. Like, let me show you once again. I was in hurry to quit. Like you can create a ping notification, like whenever the client send the message, you'll get a notification that yeah, you have received a message. Or you can add multiple users here, like this is for computer 1, this is for computer 2, this is for computer 3, like Facebook chat or something like that, where we have the names and you just click on the name and the chat is started. Okay, so if you want me to create somewhat the advanced version of this real-time chat application, then just comment down below. And also there is a poll in the community tab. So do not forget to poll on that whether you want a more advanced version of the same application. Okay, so this is it. And I'll meet you in my next lecture where we'll create something more awesome. Okay, so meet you there. Bye bye. Hello Python programmers. So in this video, I'm going to show you that how you can create a Python program to automate the tracking of the price of a product on an e-commerce website. So enough of the heavy words. Let's understand this project with a problem statement. Let's say that you want to buy the new Google Pixel 4a. Now that's not new, but whatever it is, you want to buy the Google Pixel 4a, and you know that it is gonna be on sale on any e-commerce website. Let's take the example of Flipkart. So it is gonna be on sale on Flipkart uh, in the coming 4 to 5 hours, and you don't have all the time to just be on that website and refresh the page multiple times so that you are there when the sale is on. So what you'll do, being a programmer, your first approach will be to understand the problem and create a program for that. And in this video, we'll be doing the same. So first of all, let's draw the blueprint of this project. So we'll be using Selenium, actually not Selenium, we'll be using Beautiful Soup from BS4, we'll be using Request, and we'll be using Kinter to create a small pop-up so that whenever the price goes down, the pop-up pops out. So basically we'll be creating a program which will notify us whenever the price of a certain product decreases to a certain level, or you can customize it on yourself. Okay, so first of all, let's see that what are the things that you need to install. So you need to install a few packages. First is obviously pip install requests. This will be used to get the data from website, and then we'll be using okay, so it's not import, it's pip install uh, bs4. So bs4 will be used to scrap the data from the website, and then we'll be using Kinter, and we don't need to install Kinter because it comes pre-installed with the vanilla Python installation. So now we are done with the installation part. So let's go to Google Chrome and let's open Flipkart. Okay, so the internet is not working. Let me check. Okay, so we are connected to internet and we are on Flipkart. So as you can see, I have searched for Google Pixel 4a a lot of times. So you can see it is 31,000 now. Now the actual price of Google Pixel 4a is approximately 29,000. So this is not the best buy price. So this is why we'll be creating a Python program, so that our Python program will notify us whenever the price goes down to 29 or 28,000. Okay, so what we'll do, we'll simply grab this website link from here just before this question mark. Okay, so let me show you that what part of the website web page you need to grab. So you need to grab this ID of this page. Okay, and this is a new Python file. So let me create a variable called pixel and store this link into a string. Okay, so pixel 4a, 128 GB, 4 GB RAM, and this is the ID. So let me confirm this, that this is the working ID by simply going on a new page and then running this. Okay, so yeah, It's working for us. So first of all, let's import all the libraries which are required for this project. So we'll be using requests. It should be requests, and then we'll be importing bs4 for the beautiful soup, and then we'll be importing time so that we can specify a delay like 5 to 10 seconds, so that our program refreshes the price after every 5 to 10 seconds. Okay, so then the next package that we need is Kinta. So actually we need from Kinta we need a message box. So from Kinta we need message box. Now message box will be a small message box only, which will notify you that the price has gone down. Okay, now let's start off with our program. So the first thing that we'll do is we'll create an infinite loop by using the while true, and then we already have the link. So what we need to do is we'll need to get the data from this website. So we'll use our requests library, and then what we'll simply do is we'll do request dot get. It should be a dot here. Okay, so request dot get, and then this web page link. Okay, so make sure that it is inside these brackets. Okay, now we'll create a soup variable so that we can convert this extracted data from this website, all the data that is present on this web page, into a format which is understood by soup and python, understand by beautiful soup and python. Okay, okay, so we are done till here. So what we are saying is bs4 dot beautiful soup. So beautiful soup comes inside the bs4 package, and then we are saying, okay, so the data in this pixel variable, which is the extracted data from our Flipkart web page, convert that into text, and then using the LXML format so that it is understood by BS4. Just understand that we are converting this into a form that is understood by BS4. Okay, now what we'll do is, now let me go to the web page first, and then we'll left click and we'll do inspect so that we can check that what is the function for our price. We close this first and click on this interactive icon, and here you can see that this is the div class, this long name. This is the div class that we need, this one. Okay, so what we'll do is we'll copy this, we'll edit as HTML, and then we'll copy this part, because we'll be needing this class name so that we can ask to beautiful soup that, okay, this is the class name, and find the data which is inside this class. Okay, so we'll use this soup variable which has all the data, all the classes and all the divs and all the headings is all inside this soup variable. So we'll simply say soup dot find, and then we'll define that what classes are there. Okay, so you need to follow this format, whatever I'm writing. Okay, then I'll explain you that why we are actually writing this. Okay, okay, so here we go, that this is the data that we need. So first of all, let's do one thing. First of all, let's extract the data. So we'll remove this infinite loop. We'll only check whether we are getting the data or not, because this is the most important thing in this project, to get the price basically. So yeah, price is equal to soup dot find, and then the empty attribute here, and then we are saying that the class name, the class, this was the class here, the class name is the name. Okay, so okay, now let's see that what is the type of the data. First of all, let's print the price, and then we'll see that what is the type of this data, because we need an integer to compare. We cannot compare something which is not in the integer form. Okay, so this is pretty much understood. So let's run this program, And okay, so we are getting an error. BS4 has nothing as beautiful soup. It should be beautiful soup. I guess the spelling is right now. Now make sure that this B is capital and this S is capital. I forgot that. Okay, so let's see. Okay, so yeah, we are getting the output, and here you can see that this is a BS4 element. As I've told you, we need an integer for the comparison. Okay, so yeah, we need an integer for comparison. So what we'll do is we'll store all the data that is present in this price variable into a list. Now I'm just telling you the blueprint of what we'll be doing. We'll be converting, or we'll be converting all this into a list, and then we'll be just extracting the data that we require and then converting that into an integer. It will be a very easy task, and I'll show you step by step that how we are doing this. Okay, so let's create a variable prices, and it will be an empty list. Okay, so we'll simply do prices dot append, and then we'll append this with prices. Actually, it should be price. The variable name having all the data is price, so we'll do price dot text. Okay, so now let's print our price again. Actually, the prices again. Okay, so here we can see that we got this 31,999 data into our prices variable. So now we got this into a list, but we want this in an integer format. So what we'll do, so let me remove this. So what we'll do is we'll create an actual price variable. Now I'm doing these things in total layman format because I want to make sure that the things are very simple so that it is easily understandable. So let's move on. So what we'll do is we know that this list has only one element, and the first element is the price itself. So what we'll do is we'll save this price, which is inside a list which is in the string format, inside this actual price variable. So we'll do uh, prices. Price is the variable name, and then 0 because it is present at the 0 index. Okay, so let's print our actual price, and you will see that it is having 31,990. Okay, so this is in string format. So let me show you. I'm making sure that I'm doing this step by step because I saw many comments on my previous videos that you are not showing things step by step. Okay, so I am now doing things step by step. So let me remove this now. So what we need to do is the data that is present inside this string is also having the rupee sign and also having the comma sign. So we cannot really convert this into an integer at this moment. So what we'll do is we'll take all the numbers that is present inside the string and just join them and then convert that into an integer. So what are the numbers? So first let's see that how the actual variable looks, the actual price variable looks. So what am I doing? I don't know. It should be print actual price. Okay, so here you can see that we need to extract the first, the Python indentation start from 0, so indexing start from 0. So the first element, the second element, and the fourth, fifth, and sixth element is what we need to extract. So what we'll simply do is we'll remove this now. So we'll use this variable again because I don't want to create more and more variable. So what we'll do is we'll extract from first to third element, from first to the third element, and then we'll be adding this to actual variable, and then we'll be adding this from fourth to seventh digits. Okay, so from first to third, these two, and from fourth to seven, the last three. Okay, so let's run this and let's print what is inside our actual price variable. Okay, So no, I don't want to buy. So let's run our program. Okay, so here we can see that we are getting the 31999 value, and then we can convert this into an integer number. So let's create the variable price only so that it's simple, and then we'll convert this into int, and the variable name is actual price. So now we got the value in integer format. Now let's create the infinite loop so that we can extract the values infinitely, and I'll use the tab so that we can indent all the values. Okay, so now I have indented all the lines. So we'll use time.sleep to take a halt in this infinite loop. Otherwise it will go like 1,000 times in 1 second, and this is not the ideal way. We'll use a lot of processing power, and we do not want that. So let's say that we want this program to fetch the data or to compare the price after every 10 microseconds. I know this is also a very small values, but let's say that we are comparing this after every 10 microseconds. Okay, so yep, we got this. Now the simple if and else condition. If the price is, let's say, greater than the price of the actual Google Pixel 4a is 29,000, approximate 29,000, and if it is greater than if it is less than 29,000, then we want to simply print. Now here I am showing this with print statement first so that we can check our program is working fine or not. Then we'll use the kinter to create the message box. Okay, so let's say buy. Okay, now elif, it should be elif here. Elif the price is greater than 29,000, then we don't want to buy this mobile now because it's overpriced. So actually let's do nothing here. Let's simply pass it. Okay, so we'll pass this. So yeah, let's run our program and see whether it's working fine or not. Okay, so we got an error. It is an indentation error. Okay. Okay, so we haven't specified anything here, and let's run this. Okay, so we aren't getting any output because the price is less than is more than 29,000. So let me close this and let me open this once again, and let me write something here so that we can actually get the output and we can check whether the program is working fine or not. So not buy, not buy, not buy. Okay, so let's save this and let's run our program. Okay, so we are getting an error here. Okay, so the none type value has no attribute as text. Okay, so this is pretty strange. Okay, so we are getting not by, not by, not by, and after 10 seconds we will again get not by, not by, not by. So let me wait for 10 seconds so that I can confirm. Okay, so yeah, we got not by, not by, not by. So our program is working and it is working fine. Okay, so now let's add the message box so that we can give a good GUI look to our project. So what we'll do is we'll only change this. Actually, let me close this. Now, if any of our viewer is using this editor, then can you tell me that how we can stop this program in between, because I am not getting that. Okay, so what we'll do is we'll create a Kinter message box. So Kinter dot message box, and we'll use this show info. Now there are a lot of methods to create a Kinter GUI for pop-up. You can use the orthodox method of creating a Kinter GUI, and actually it is the ideal way. You can actually customize the message, but I'll be creating a simple GUI show info pop-up so that we can pretty much make a basic project. Okay, so the title of this GUI will be, let's say, hello, and the message that this GUI will show is, let's say, bye bye bye. Okay, so let me save this and let me run our program, and actually nothing will happen because the price is more than 29,000. So let me copy the same to this also, so that we can confirm that our GUI is also working. So not buy, not buy, not buy, not buy, not buy, not buy. Okay, so let me save my program and let's run our program. Okay, so kinter is not defined. Okay, so we need to import kinter also. Import kinter, and then from kinter we need to import the message box. Okay, so let's run this. Okay. Okay, so yep, we got the message of hello, not buy, not buy, not buy, and this is how the project will work. So let me close this. Okay, so yep, it will take some time. Okay, so yep, this is how this project will work. Now you can customize this project as you want. You can create a proper GUI for this. I showed this show info to just to give you an idea that this concept can be applied to this project, and you can customize this project as you want. You can add multiple products here. You can create a GUI to select the products. Now the possibilities of this project are infinite, and you can really create awesome projects. Okay, and I expect from you to create awesome projects. Okay, so this is it, and I'll meet you in my next lecture where we'll create something more awesome. Okay, so meet you there. Bye bye. Hello Python programmers. So in this video I'm going to show you that how you can create the tic-tac-toe game using Python. So let me first walk you through the final output of this project. This will be a GUI, and the player 1 is X and the player 2 is O. The first chances of the player 1, there you can see. And now you can see that the player 2 has 1, which is O, from the middle column. So okay, so let's talk about the packages required. You only require Kinter for this project, and as it comes pre-installed with your vanilla Python installation, you do not need to externally pip install that. So this project will be divided into two videos. In this video I'm going to show you how to create this GUI and create all the buttons, and how to make this cross and O appear on the button when you click on them. In the next video we'll apply the permutation and combination to see that which player has won. Okay, so now we are into a new Python file. Let me import the library required, which is only Kinter. From Kinter, import all or import star. Now let's create the tk variable, which is root here. Then we'll create our first two labels, which will say that the player 1 is X and the player 2 is O. So L, make sure that this L is capital here of the label. Then the name of the class variable, the text is player, this is not a list, player 1 is X and the font is gonna be times. It should be inside the inverted commas. It should be times, and the size should be 15, and let's say let's not make it bold. So let's grid this into our Kinter window, add the row 0, and at the column there should be a comma here. Add the column, let's say first, Then we'll create another label, so I'll just copy paste this here. There should be L2.grid, and here also L1.grid. Let's make this L2. The text appearing will be L player second is equal to O, and the font remains the same, only the column changes. Okay, so now let's create our 9 buttons. Button, then it should be in the root variable. The width of the button is 20, and the height, there should not be a equal to sign here, and the height is equal to 10. You can clearly experiment with these values, and the command that this button will trigger is a lambda function and it will call the function define sign, which we'll be creating in just a few minutes, and the value which will be passed is 1 because this is button 1. Now let's grid this into the row first and at the column first. So let's create 9 of them. There should be equal spacing so that there is no confusion. So how many of there are? 1 2 3 4 5 6 7 8 9. So there we have 9 buttons. Let's rename them and grid them at different rows and columns and create the lambda functions for each of these buttons. Okay, so we are done editing them. Let's close our main loop dot main loop. Okay, so let's create a define sign function so that we can display that whether the player 1 or cross is playing or the player 2 O is playing. So first of all we need to create some variables here. The first is y, it should be a string, then x, it should be an integer 2, then player 1, it should be a list, and then player 2, it should be also a list. Now let me give you a brief introduction what these 4 values are, and by the way, while creating the functions you will clearly understand why we are using these variables. First of all, the y variable will store whether the button is cross or O. The x will say that whether the player 1 or the player 2 is playing, and the player 1 and player 2 list will store the number of buttons in them. Let me show you the implementation of this. So we'll create define sign, no parameters are given here. Then we'll call our global x comma y and global player 1 comma player 2. So if actually there is a parameter, it should be number, because this is what the lambda function is sending. If the button 1 is pressed, then 1 is sent to this function. If 2, then 2. If 3, then 3, and same for other 9. So if the number is equal to 1, then what will happen here is, if x modulo 2 is equal to 0, or this number is even, which says that the player 1 is playing, then the y will become x, which is for the player 1, and then we'll append the player 1 list. It should be append with this number, so that we can have the list for both player 1 and player 2. Now let me write the whole code, then I will explain you in one go. So we'll print the player 1 just to make sure that everything goes well, and elif the x modulo 2 is not equal to 0, or this is an odd number, then the y will become O, and the player 2 dot append the number, and then we'll print our player. Then we'll simply b1 dot configure text is equal to y, and x will be increased with 1. Now let me explain you this bit of code, because the same concept will be applied for all the buttons here. Now first of all, the value of x is null, and y is null, x is 0. The player list is also empty for both of the players. Now we have called the global variables in this function. Now if the number is 1, or the player has pressed the button first, then what will happen is, it will check whether the number is even or odd, because after pressing of each button, the x is incremented by 1. So if the player 1 is playing, then this will be a even number, here you can see, and if the player 2 is playing, this will be a odd number. So you must be getting what I am saying here, right? Let's say that the player 1 is playing and the number is even, so this will go into here, and y will become x, and then the player list is appended with the button number, which we are gonna use to see whether there is any possibility of the player 1 has won or not, and the same applies for the player 2. So we are gonna copy this for the others also. It should be copied 9 times. I haven't counted how many times I have pasted it here, so let's rename them. We'll find that out later. Should be 2, and there won't be any changes here, only the b2 is configured. If the number is 3, then no changes here, only the b3 is configured. b9 will be configured. Okay, now we are good to go, I guess. Let me make sure I am not missing anything. No, we are not. So let's save this and run this by my newly discovered command shortcut ctr plus b. And if I press first, then it is playing, it is displaying O. Just a second, let me see this. Okay, so actually we have an extra b1 here, number 1 here, but I don't think so that it would matter, and it will matter. And there you can see we are able to get the cross and O pattern. So this was the aim for this video. Let me just sum up this video by explaining you the whole concept again. First of all, we have created these 9 buttons which are of the 3x3 matrix format, and each button has the lambda function command which gives the define sign function their button numbers. And in our define sign function we are getting 2 things done. First of all, we are checking that which button has been pressed, and then we are again checking whether this is player 1 playing or player 2 by simply using a variable and checking it whether it's even or odd. Then we are defining if it is player 1, then the value printed will be X. If it is player 2, then the value printed is O. And then we have appended the list for them, here player 1 and here player 2. Then at the last we have configured the button to display, and then we have incremented the value so that the next chance goes to the next player. So first of all, let me explain you that what are the conditions of any player to win. A player wins when if he claims all the rows, like the first row, the second row and the third row, or all the columns, like the first column, second column or third column, or the diagonal of the 3x3 matrix. So I guess you know what is the rule for winning of a tic-tac-toe game. So let's create that logic. First of all, call the library from iteration, import permutation. So we'll use the mathematical concept of permutation. This should be permutation, and let's list out the possible values. Okay, so first of all we have this 1 2 3, then 4 5 6, then 7 8 9, then we have 1 3 5 and 2, whatever it is. We are having 9 possibilities, so let's write them down here in each variable. Let's say set1 is equal to permutations of 1 2 and 3. So what this command will do here is it will find all the possible combinations of the 1 2 3 list. Now let me show you that how this works. Python. Now we are gonna import this package, so I will copy this from here, and this package also comes pre-installed. There is no package as iteration. It should be iter tools. Actually it is not iteration, it is iter tools. dot import permutation. Okay, and then let's say we want to get all the possible uh, combinations of 1, 2 and 3 values for I in list of set 1. Then we'll print I here. If we press enter, we can see all the possible outcomes: 1 2 3, 1 3 2, 2 1 3, and all the possible outcomes of the 1 2 3 set. Now let's write it down for all the possible combinations. Okay, so there we go. We have we have 8 possibilities, 3 of the rows, 3 of the columns, and 2 diagonals. So let's create a for loop to extract each set from here, from set 1 comma set 2 comma set 3 comma set 4 comma set 5 comma set 6 comma set 7 comma set 8 comma there are only 8 sets here. Then we are gonna iterate in each list of this set. Like each set has like 8 or 9 values, so we are gonna iterate to each value list of I. Then we'll write one list command. Let's create a variable player1 to all the elements. Let me write this, then I will explain you. So what is happening here is we are first of all extracting each the element from the player 1 and checking that all the elements of the J of the permutated lists is present in the player 1 list or not, and if it is present, the player 1 value becomes true. Let me show you what I'm going to do here. Let's call Python first, and we have to call the iteration package, sorry, the iter tool package. Actually we don't need iter tool. First of all, let's create one list. Let's say 1 2 3 4 sorry 1 2 3 4. Then we'll create another list with, let's say, 3 and 1 and 4. So the order of both the list elements are very different. Now let's write this command here and check whether this command is able to find out that all the elements of B are present in A list or not, in the A list, and the value is returned true. Let's change the B list and add one more value. Let's say 148, and let's write this command again, and there you can see it's false because one extra value is here which is not present in a list. So this is how it works. Now let me create the same for the player 2, and I'll simply copy paste this one. Only the list name will be changed, so it will check whether all the elements of our J list are present in our player list or not. And if the player 1 is equal to true, or the player 1 has 1 because it has satisfied all the condition for winning, then we'll simply write player 1 wins. And then let's import the message box package of Kinta so that we can create a pop-up message from Kinta dot message box, import show info. Now if this is true, then we'll simply write show info, and this is the title. Let's say game result, and this will be the message body. The player 1 has 1, and let's do the same for the player 2 also. If the player 2 is equal to true, then the player 2 wins the game result. The player 2 has 1, and we want to break the loop after this is done, so we'll write break here. And if this is not the case and there is no winner, then we'll simply pass. So this is it that you have to do. Yes, this is it that you have to do to see that which player has won. So let me save this, ctrl+b to run, and we are having a error because for I in. Okay, let me run this again, and 0. Okay, let's make the player 1 win, and there we go, the player 1 has won. So let's try whether the player 2 condition is working or not. The player 2 is O, so let's make player O wins, and there we go, the player 2 has won. So this was a short but a very interesting project, and I also learned a few things in this project, like how the permutation in Python works. I mean, I have done the permutation and combination in mathematics, but to use this in a real life base is really very interesting. So this was a fun project for me also, and I hope you'll like it. And if you like it, in my channel I create such short but awesome projects. So I'll meet you there. Bye bye.